Okay, so now we're looking at section 2.5. We're working with solving equations, so the same thing that we were just doing before this, but we're working with fractions or decimals. So what this is a hint or a recommendation or a trick, quote unquote, if you want to think of it that way, of how you can deal with fractions that are showing up and decimals showing up in these types of equations. This is not a process that you are required to follow, but this is one that I find very, very helpful for students if you don't like working with fractions in these types of problems. And then subsequently, if we're working with decimals as well. So the main process with this, and we'll go through two examples. Determine the lowest common denominator, the LCD, between all of the fractions in the problem. That doesn't mean, okay, looking at our first example, it doesn't mean just the left side. It means everything here on the left side and everything on the right-hand side. Again, you're looking at both sides of the equation. You're looking at every single fraction that shows up. So you are trying to find the lowest common denominator between all of the fractions in the problem. You absolutely must do this. You must take into account every single fraction that shows up. If you don't do that, you are going to get wrong answers, or at least you have the possibility of getting wrong answers, and we don't want that. The next thing we are doing is we're going to multiply both sides of the equation, meaning all of the terms that we are being presented, by the lowest common denominator to eliminate those fractions. And from there, we're going to solve the resulting equation just like we've done with our previous work. So essentially our first two steps, finding the lowest common denominator and multiplying everything by that lowest common denominator, gets rid of the fractions, and then suddenly we are left with a much nicer problem. No fractions are showing up in there. So I'm going to go through our first two examples here. I'm going to show the full process with our first example, and then again, just looking at time, I'm just going to show how to eliminate the fractions with our second one and get these set up. And I'll let you guys go through and work through this in a bit more detail on your own, because I do want to get to the decimals here. So working with our 2.5 stuff, our first two examples, I'm going to jump us over to our whiteboard. I'll work on these from here. So whiteboard, I'll move us down here so we have some space for this. Okay, so we're working with our first example here. And we were given 1/3 W plus 5/4 is equal to W minus 1/4. It's our original problem that we've been given. So again, our first step in the process, a suggested process for working with fractions, I need to find and determine the lowest common denominator between all of the fractions in the problem. So that means I am taking into account fraction here, fraction here, fraction here. So our lowest common denominator between these things is going to be 12, the smallest number that 3 and 4 both evenly multiply into. So our LCD is 12. Now, this next step, the second step in the process, this is extraordinarily crucial that you set this up and you do and go through this process or this part of the process very, very carefully. A lot of people mess this up for themselves, and it absolutely just it costs them a lot of points. There are two ways you can write this for yourself with how you can make this process work. I'm going to show you both of them in the gory detail of how you can make this happen. But our second step, we are told multiply both sides of the equation, i.e. all terms, by the lowest common denominator to eliminate the fractions. I'm going to show you guys two ways that you can write this out. The first way that leads into the second one, but you are free to use either one that you would like. So I'm multiplying both sides of the equation. I should probably write the correct thing down. So I'm multiplying the entire left side by 12. And I'm multiplying the entire right side by 12. Now here's the part that a lot of people mess up on. And if you're seeing this, you're on the right track, but again, I would advise caution with this. If you're seeing, well, I have a 12 here, and I have a 3 down below, so these things could cancel. And I've got a 4 there, and that 4 and 12 can cancel. You're looking at it in the right way of things are going to cancel out. You're 100% correct on that. It's the way that we are writing this thing out to have it cancel that is crucial. So if from this step you start doing cancellation, you're doing it wrong. We need to go and make our next line of work to allow that to happen. So what that's going to look like is this 12, I'm going to use gold here, this 12 would need to distribute through to everything inside the sets of parentheses. So what this looks like, and again, when you are going through this process, you can use either both of these steps or just the bottom step here, but you absolutely need to do at least the bottom one. So as it says in our second step for our process, multiply both sides of the equation, i.e. all terms, by that lowest common denominator. So what that looks like, if you look at this individually, if we distribute that 12 through, it's a better 12 here. Means every single term is multiplied by 12. This step here is crucial. You absolutely must have this step written out. If you do not do this, you're going to, and you start canceling things otherwise, there's a lot of room for error. A lot of people get a lot of wrong points, or miss a lot of points, I should say, because of that. So the second line of work, one that we have right here, is optional. If you want to write it out in that form, we'll do it in a different color, makes it better. If you would like to write this second line of work out, you're welcome to do so. It is not required, but you're welcome to write it out that way if you would like to. The third line of work, where every single term is multiplied by that lowest common denominator, you absolutely must do that. If you don't do that, you're going to get wrong answers. So from here, now we can go through and we can start canceling out these fractions. I have a 12 times a 1/3. The 12 and the 3 are going to cancel out. And I'm going to be left with 4 in here. So 4 times W, it's going to be 4W. The 12 and the 4 are going to cancel. It's going to be a 3 and a 1. 3 times 5 is going to be 15. I get 12W. And then the 4 and the 12 cancel over here. I'm going to get -3. And suddenly now my fractions are gone, and I can work through this thing exactly like I would with any of these other problems. So I'm subtracting 4W from both sides. I'm getting 15 is equal to 8W minus 3. I'm adding 3 to both sides. And I'm getting 18 is equal to 8W. Divide both sides by 8. We're getting 18 over 8 is equal to W. I'm just going to reverse this because I like having the variable on the left-hand side. Reducing the fraction down, I can divide both of those things by 2. And I'm getting 9 over 4. And I have my final answer there. Okay. So we'll take a look at the second example, just making sure I'm moving us here with some space. And again, just looking at the time that we have here, I am going to go through the example of how we set it up and we at least eliminate the fractions. After that, it's basically review of material that we have already done until now. I just want to go through and show you guys how to do it, or to get those taken care of. So we have, I should probably put the 1 in there. There we go. So we not only do we have fractions showing up in this problem, we have kind of grosser ones. There's a lot of stuff that's going on in the numerators here. So again, all the more reason of why we want to eliminate and get rid of these fractions in the problem. So again, just like we did with our previous one, I need to first and foremost determine the lowest common denominator between all of the fractions in the problem. So I've got a fraction here, I've got a fraction here. I want to find the lowest common denominator between those. And in this instance, the lowest common denominator is going to be 8. So I'm going through this again. I need to multiply both sides of the equation, i.e. all terms, by that lowest common denominator. So I'm going to show you guys how we can do that. I'm going to skip that intermediate step and jump right into where the required step that we need. And again, that intermediate step, you are more than welcome to write that out for yourself if you would like to, if you're comfortable with doing that. If you're more comfortable doing that, that's totally fine. I'm just doing it this way just for the sake of showing you guys a different way of writing it out, an alternative method. On the test or anything like that, I'm happy with whichever way you guys would like to do that. But again, this is the required step that you must have in there. So looking at each of these now, we're looking at the left side. I have an 8 on top and a 2 down below, 8 in the numerator, 2 in the denominator. The 8 is going to become a 4. The 2 cancels and becomes a 1. And I would recommend, if you are not comfortable with multiplying these things together, your next line of work be written out like this. Which is perfectly acceptable. And we have 8 times 1 is going to give us 8. And on the right-hand side, we have an 8 in the numerator, 8 in the denominator, so each of those are going to cancel. Those are each going to become 1s. And on the right-hand side, we have 5x plus 10. Our fractions are gone, and we can work this thing out, and we can find x equals, I believe the final answer for this should be 2. But again, this is a review. Basically from here, this is stuff that we just went through in 8.5. So it should be a review at that point in time to go through and solve that thing. But again, getting rid of our fractions, find that lowest common denominator, and then multiply each term in the problem by that lowest common denominator. This is where we are canceling these things out. We are not doing it. If we are going to use this method, we are not doing it in this step. You must distribute through, and then you can cancel things out. Okay. Now I'm going to jump us back to our notes that we have here to go through the decimal side of this thing. So as we are going through these, we are working with decimals instead. Again, this is the suggested process that I recommend for you guys. What's going on here? Sorry, technical difficulties. What's going on with this? Okay, there we go. Got that. Okay. So my recommendation, if we are working with decimals, I think this is probably the most straightforward way of doing that. Look at each decimal as an equivalent fraction. So we want to rewrite all of our decimals into fractions. So let's say we have it working with the decimal 0.07. I want to rewrite that into a fraction, which is going to be 7 over 100. We'll see some examples of this here in a second. From here, now instead of having decimals in the problem, I would have fractions in the problem, and we can use our process that we just went through to go through and solve these things. So we determine that lowest common denominator between all the fractions, multiply everything by that, and then we have our final answer from there. Okay. So one of the really nice parts that we have showing up with this, and again, this is an instance where and why you would want to have a graphing calculator. is we can actually have the graphing calculator convert decimals into fractions for us. So if you have a graphing calculator, a TI-83 or a TI-84, I invite you, now is the time to get that out. Okay, so I'll give you guys a minute or so to do that, and I'll show you how we can convert these decimals into fractions and then solve these problems accordingly. So I'm going to jump us over to a program that we can use that's going to show us, so emulate this thing. So with the graphing calculator, so our first example that we were working with, we were solving an equation. In part of that, we were starting with the decimal 0.6. And if we want to convert that thing into a fraction, we can go through and have the graphing calculator do that for us. So the way we're going to do that, we want to enter in the decimal we are starting with. So I'm entering in 0.6. And then on the left-hand column of our calculator, so the left-hand column, 3 down, we're looking for this math option in here. So click on math. And then we're going to be using the first option that shows up, frac. This is one of the most handy tools that this calculator can work with. It reduces fractions. It fully rewrites things into fractions. It's fantastic. So from here, we're selecting option 1. You can hit enter, and then enter one more time, 3/5. Bam. We now have this thing written out as a fraction, which is fantastic. So for going through and solving that thing, I've just converted that decimal into a fraction, and now I can solve this thing using the method that we have for solving these equations fractions that we just went through. Looking at our second example from the notes that we have, I'll jump us over here just for the sake of being able to reference these. So we work with 0.6 here. With our second example, we have 3 decimals that are showing up in here. So we're going to go through, and I'll show you guys with the graphing calculator, how you can rewrite each of these, again, into a fraction form. And the process isn't going to be much different. We're just going to be entering each of these things in, and then hitting math frac, and it's going to reduce that down for us. So we'll work with each of these over there, and then we'll come back to where we're at over here. So jumping over there to our graphing calculator. If I want to convert 0.05 into a fraction, again, I'm going to enter 0.05 into the calculator. Going over to math on the left-hand side, I'm going to do math, option 1, math frac, enter. So 0.05 is 1/20 as a fraction. Our second decimal that we were given is 0.25. So I can go 0.25 math frac, enter, and that fraction, or that decimal, is now 1/4. And our last number that we were working with, we were given 3.05. It can do that also. 3.05 math frac, enter. 6/20. Okay, it's kind of a gross fraction, but it is a fully reduced fraction for us, which again, very, very nice and handy part about this tool. This will fully reduce fractions down for you. It will convert decimals into fractions, add fractions. It's fantastic. Math frac is one of your best friends you can possibly have in this class. So this is one of the ways that we can go through and work with decimals showing up in these things, in these types of questions. Now, I believe it was covered in Math 70, but this is also as a generality, it carries over into here. When you have decimals showing up in these problems, you do not have to convert them into being fractions if you do not want to. You have the option of working through these problems and these equations, just leaving the decimals in here. It's a totally reasonable thing that you can do. The main reason why I would advocate for, I would recommend you take in the possibility of converting things into fractions is because as soon as you have to start adding, subtracting, multiplying, and dividing decimals together, you have to start then going into the issue of, well, how do I round this thing? Is there a certain way I should be rounding it earlier or later or anything like that in the problem? And with fractions, we don't actually need to worry about that in any way, shape, or form, because fractions, if we go through our process, like we just did up above here, fractions are automatically going to take care of that for us, and we get some fraction answers, and we only need to worry about rounding at the very, very, very end of our problem. So when we have these decimals showing up, again, you have the option of rewriting them into fractions, eliminating those fractions, and working with the resulting equation. Perfectly viable. I recommend doing that if you can help it. Or you can leave everything as decimals. You could and probably will get some gross decimals showing up, but you can work out the rest of it that way, just using decimals in your calculator, going through things from there. Take a quick drink here. Something in my throat. All right. Excuse me on that. Thank you. All right. So the last thing I wanted to make a note of, and it's particular to this second equation that we have here, and it's looking at our first part of this. And this is just to show you guys some of the different ways that you can write and format these equations with fractions. So if you were to rewrite this 0.05 as a fraction, you can also write it as 5 over 100. It's an equivalent fraction. We didn't use mathfrac for this, so 5 over 100 is still an equivalent fraction what we worked with. So you can rewrite it into this form we have here. So decimal directly into fraction. You can also rewrite this thing as this a minus 5. Well, this is also assumed to be a fraction over 1, as it's written here. And then you can combine these things together and get 5 times a minus 5 all over 100. So equivalent statements mean the exact same thing, but it may be helpful if you are going through and multiplying and canceling things out to have all of this combined as a single fraction versus a fraction out front multiplied by something, a fraction up front multiplied by something. Now everything is encompassed as a single fraction in here. I think this is particularly helpful when we are going through and multiplying every single term by that lowest common denominator. I think this helps make that a bit easier to see where things cancel out accordingly. But again, it is optional. It is not a requirement. It is just another way that you can go and write this thing out and organize it for yourself. You're more than welcome to leave it in this form and then cancel things accordingly as you would go through and do that. It's 100% your choice, your option on that front. So we have a lot of flexibility with decimals on how we can go through and work with these things. We have the option that we have here. Again, we have that previous one of saying, I don't want to convert it to fractions at all. Just leave everything as a decimal. That works too. Again, there's pros and cons to both methods, but I do want to present this as just another option you can use on the homework and on the test as well. And on the test, if something shows up like this and I say solve the following equations, I do not care if you want to leave this and solve this out as decimals. I don't care if you want to convert this into fractions and then solve it out. It's your choice. There are advantages to doing it one way. There's advantages to doing it the other way. It's going to be your call on what you want to do. You need to pick which method you want to use and then move forward with it. But I would highly recommend giving this a try on the homework just to see if it may or may not be a bit more useful to you, or maybe a bit faster or easier, or maybe you like working with it in this way. But just for the sake of getting some practice with it, I would recommend that. I think, where are we at here? Yeah, our second page, this material, yeah, it's just more examples if we went through these in class. Okay, so again, not a whole lot With the 2.5, it's just some additional options on going through and solving equations with fractions or decimals. I will tell you all right here, right now, you can absolutely expect fractions showing up on tests. I think I said this yesterday in the syllabus day or the intro day. I'll say it now, I'll say it moving forward. Fractions are not going away. You will absolutely be seeing problems like these on the test. Same goes for decimals. You can absolutely be seeing problems like this on the test. You absolutely want to get comfortable with this, because if you are not, this is going to be a very, very long quarter for you. So this is everything for the 2.5 material. I'll end the recording here, and I'll open it up to any questions that you guys have from here.